Blissful ignorance, sleepless nights, error-free failures. Those are some of the experiences I've had when working on monitoring throughout my career for different companies and on different products. Hi, my name is Kamil Dziubliński, and I will be talking today about observability. Mastery is a journey, not a destination, Tim Ferriss said. He's one of the best-selling authors and also advisors on companies like Uber and Evernote. Although I believe something along those lines was probably said by some sage in the Far East a couple of thousand years ago. But I still feel it applies now, and it definitely applies to this topic. So I think to achieve mastery here, you need to embark on a journey. And today I would like to share the road we are taking on that journey at Xapo. And hopefully this will allow you to travel faster and avoid some annoying, surprising obstacles that happen. But why do we even care about monitoring of our systems? I think there are two reasons. One is very obvious to everyone. We want to provide great experience for our users. And you cannot do that if you have unstable system. But the second one is a bit less obvious, and it's actually that it indirectly affects time to market for your engineers. Because the better monitoring setup and the better focus on everything, there is less disruption for engineers in day-to-day work. And they can focus on building actually what products usually want them to build. So, a few words about myself. I have 17 years of experience in software engineering. I started as a Java engineer, later moved into working on distributed systems, like as a big data engineer. That word is not so, that term is not used so much anymore. Then I became a tech lead in the same area. So with the teams, we were working on building financial reconciliation systems, data lakes, both on-premise and also in the cloud, using open source technology, but also cloud native technologies. But 3 years ago, I moved into a director of engineering role. And 1.5 years ago, I joined Xapo in the same position. So what is Xapo? Xapo is the first in the world Bitcoin bank situated in Gibraltar. So we offer US dollar account and Bitcoin account. But the target for Xapo is countries where it's actually quite difficult for users to secure their wealth because of the government, because of hyperinflation, countries like Latin America or South Africa. And indeed, the mission of Xapo is to protect your users' wealth. So there are a few cool things that we did as the first bank in the world. We replaced, for example, Swift rails, the old Swift rails, with actually withdrawals and deposits with stable coins like USDC or USDT. So you know it happens instead of few days. It can happen now in a few minutes, a transfer, and actually it also doesn't matter if it's middle of the night or a weekend. Another cool thing is integration with Lightning Network as the first bank. You can pay for your coffee with Bitcoin if you want. So many things to come. So before we jump into the core of the presentation, if you will have any questions, just go to Slido, use hashcode GeeCON, and we are in the room number 10, and I will be answering the questions at the end. So I like to compare the maturity of monitoring to cycle of adolescence, because when we are starting to work on an application, it's in its infancy stage and it's not yet on production, it's very important to start thinking about observability, because it's a trait of the system. It means your system or your application become observable. And if you don't do that, and you go into the toddler phase, so your application starts walking and you are having first customers on production, very often those customers will become your monitoring, and they will be letting you know about problems that you don't even yet see in your own systems. So let's say you're in that situation and you invest a bit more, you set up an infrastructure, perhaps Grafana with Prometheus, or you buy something paid like Datadog, and you start sending right metrics to that system. You usually should graduate into a teenager phase where your customers are just sometimes faster than your monitoring. So they will be letting you know about problems that you already can see on your side, but perhaps you need to fine-tune some thresholds, set up some new alerts, perhaps introduce more formal process like on-call that will allow you to catch problems after hours or even during the weekends. That should then allow you to move into an adult phase where your monitoring becomes faster than your customers, And of course, the sweet spot is fixing the problems before anybody notices. So as you can see, I never talk here about not having problems. We all know this is impossible. The incidents, they will always happen. So it's just the case about catching them as fast as possible and lowering the impact of them. So when I joined Zappo one and a half year ago, I was sniffing around to see what to focus on. And I had the gut feeling that the reliability part needs a bit more love, but I wanted to validate that based on data. So because we all know there's always things to do from technical debt and also features that need to be built, security, architecture, you name it. But unless reliability is in a satisfying state, I feel this should really become a high priority. So cool thing was that they were already tracking DORA metrics. So if you are unfamiliar with DORA metrics, those are 4 metrics that are suggested to be tracked if you want to see if a company is a high-performing software company. And those are metrics that track how fast you deliver software, but also how reliable it is. It's explained at much better length when in the book called Accelerate. So if you didn't read the book, I really recommend it. It's a great book. But one of those metrics is mean time to resolution. And this is about how fast are we at resolving our issues. And so we started looking in those data, they already had it. And as part of that, there's also mean time to detect. So how fast you detect a problem before you even start working on a fix. But then additionally, we wanted to establish a relationship with customer support. And that then allowed us to start tracking from their side, from customers, how many, for example, incidents are being escalated from customers. So all that together, we knew we need to focus on that. So starting a bit from the end, we invested a lot of time last year into this, and we were actually able to lower that metric by 97%. But when we knew we want to focus on that, then there was a question, okay, so what to focus on first? And this brings me to what I like to call a monitoring prioritization pyramid. And those are the things that you should be starting with and then building on top of them to really have a correct order of them when it comes to implementing observability. So before I will jump in each of those in more depth, so let's go quickly through them. First level is standardization of baseline monitoring, and it's actually really good to invest into automation here. Then you will usually have to go through a period where there is a bit of stabilization of the alerts, so getting rid of the noise, getting rid of the false alerts. Then you can start thinking about more custom metrics, domain metrics, and here we have business domain metrics, but also technical domain metrics. That data then should allow you to create more high-level dashboards for monitoring that will then give you a health of your system at the first glance, so like in one spot. And then you can think about, as a cherry on top, automation of your service level indicators. And even if you already have a tool that does that for you, but you didn't do the work before that, I believe that you cannot really trust that data. So starting from the bottom, I feel that step is actually quite counterintuitive because it's very tempting if you already have some infrastructure for monitoring to just allow your teams to go and set up the monitoring the way they want. So for example, that will then differ per team depending on the DevOps culture that exists in a certain team. But I was yesterday in a talk from Rustam, a lightning talk, and I really liked his term. He said that we need to avoid ClickOps. And I said like, damn, this is great, I'm stealing this one. Because that's true, we just don't want to, it doesn't matter if we are provisioning infrastructure or you know, configuring CI/CD or configuring monitoring. It's really dangerous to allow just doing that in the UI that it's provided. It's much better to try and store that as a configuration. So we knew we want to do that, but then it's also a matter, what do you want to measure first? And then this brings me to something that is called in DevOps community as 4 golden signals. And those are 4 categories of things that you should track first to be sure that your services are healthy. And the first one is about latency. So those are things like, you know, HTTP response time or lag on your processing queues. And here it's also quite important to distinguish success latency from failure latency, to not track them together, to not commingle the data. Second golden signal is about traffic, so how much throughput is going through your service. So here you want to track things like HTTP requests per second, number of transactions per second. If it's about retrievals, if it's about storage, it's then retrievals or writes per second. Third one is about errors, and here you can have very explicit errors. Very explicit errors like 500s, but you can also have implicit errors, like for example 200 responses with inaccurate content. And then you can also have errors by policy. So for example, let's say our policy says that we should be responding to requests under 1 second. So that means that all the responses above 1 second would also be considered an error. And the fourth one is about saturation. So that means how full is our service. And here we usually track infrastructural pieces like CPU, memory, storage, network. And this is also a great leading indicator, because here if you get to the warning thresholds, you can very often see problems in the other golden signals, like for example, throughput can drop, or your latency can increase, or for example, you might start seeing some errors because you cannot process things in time. For all those 4 golden signals, I really suggest that you work with percentiles, not medians and not averages, like for example 95th percentile or 99th percentile. This will really allow you to see the experience of majority of your users and track that. So for example, 95th percentile of 100 millisecond latency, it means that all the requests, that 95% of requests are being returned 100 milliseconds or faster, and only 5% is then slower. So this allows you to eliminate some outliers when you set up thresholds and alerts. And then you can always, of course, look into those anomalies separately. So who of you knows Terraform? Yeah, we all know. We all love Terraform. So as I was saying, we wanted to create baseline monitoring and automation for our engineers. So we wanted to be sure that there are almost like building blocks that our teams can use when setting up monitoring for their services. And we internally at Zappo, we use New Relic for monitoring, but it doesn't matter what you use. Terraform has providers for most of the systems that I know, at least, like New Relic, Grafana, Datadog. And here it was actually for us really important to be able to have a central repository with so-called building blocks, I'll be showing in a second, and then configuration of the dashboards in the repositories of services themselves, using those building blocks. So this is one. Yeah, I wanted to see how it looks. So this is one of the building blocks, so to speak. This is just a snippet from the Terraform, and this is about the panel that is about server throughput. So it tracks requests per minute. And we have many of those that then in a central configuration of a service are being kind of put together. So the New Relic query that is on the bottom there, normally you would have to go to UI and put that query there. And like, if we allow ClickOps, so to speak, then it means that there can be differences between the team, not only differences in what they measure, but even how they measure it. This team will use average, this team will use 95 percentile, different intervals. So it's really nice to provide standardization from the get-go. And that's why I'm saying it's a bit counterintuitive, because we often like to start something and then automate it. Here, I think it's actually worth doing a bit more effort at the beginning and have a payoff later on. Another important thing that we wanted to store in the config was configuration of alerts. So we wanted to make sure that if a team is already if a team configures a service to use that monitoring, we wanted to be sure that at least some default alerts are going into the right channels. So in that case, Slack of that team, but also PagerDuty, which we are using for tracking incidents and also rotating on-call shifts. So here I suggest if the tool that you are using provides that, to set up the default thresholds for alerts with standard deviation. because then you don't have to work with static numbers, which are actually quite hard to set defaults across many different systems. Of course, here we provide possibility for overriding those thresholds, but if you use standard deviation for default, it will check the anomaly. It will, for example, check that period of the day a week ago, and then if there is anomaly, trigger an alert. So, and this is, for example, a snippet from when we put those things together. And of course, this is just a part of it. I wasn't able to fit it on the screen. But another thing that was important for us, that the arrow points to, was that we wanted to distinguish severity of alert. We didn't want to treat everything as critical, because it's never like that, right? And for us, the definition of criticality was it should wake up an engineer at 3 a.m. at night if it doesn't work, and that person, she or he, should work on fixing that. So how did we go about finding what's critical and what's not? We had a conversation with product, actually, and we asked them what do they think, which features of the application are actually critical, and there was a bit of negotiation there, but we came to an agreement, and then we mapped those features into services that are responsible for those features, and then we stored that into the configuration together with the rest. And additional bonus from that approach was that we were then able to prioritize work for the critical services first, because Zappo has quite a lot of services, and then, you know, leave for the second iteration the non-critical ones. So this is an example of dashboard that is actually being generated from the Terraform. So nothing here is being manually created. All of our dashboards for right now, 100% of our services are generated from the code. So you see here multiple tabs because, no, okay, so it's just on that screen. I was wondering because there is a name on top, compliance V2. So this is a service responsible for compliance, obviously, and those dashboards they are created in a way that they respond to the technical nature of that service. So it means depending on what technology they use, they might have different tabs. And some are the same for everything. For example, application is always there because we always want to track certain things. I mean, depending here actually if it's an API service or it's just like an asynchronous service. But here we have server throughput, some golden signals that I mentioned, like errors, and then there is also additionally SQS queues because that service reads also from the queues. So we track here lag, we track here how many messages are being sent. But you can also see here, there is a tab database MongoDB because it uses Mongo. But if we go to the next service, which is Alfred, which is our butler because it's responsible for onboarding, the first three tabs are the same, but then you see the difference, right? There is a database for RDS, not Mongo, and then there is additionally tab for Redis, and they all track different things. So this approach really allows you to scale your company, scale your monitoring together with your company. So it doesn't matter how many teams you create, you add more teams, your teams grow, you add new services. If that becomes a requirement for your definition of ready or done, definition of done for the services, you can sleep tightly and be sure that at least the minimum amount of quality is always applied when it comes to reliability for your services. And I really work with many engineers that think that that very often that responsibility of running the production service is on ops team or SRE team. But I don't agree with that. I think that there is very much value with promoting DevOps culture amongst backend engineers, because those are people that actually know those services the best, and they can really fine-tune things to a different degree than if it's just left to external team that, you know, overwatches the whole infrastructure. And it also creates collaboration between those two teams. So the next step in that pyramid is about stability. So very often when you already set up your monitoring, you will have a lot of noise. And it's actually a good thing, because I would rather recommend this way than the other way, where you might have not enough alerts and actually miss some incident on production or find out about it from customers. So, but you need to pay attention to really work and make sure that you minimize the noise, because very often it can actually lead to monitoring fatigue. And who of you have to wake up at night to fix a production issue? Okay, good, few hands, so many of you are lucky. Yeah, it's very annoying if that production issue, if that alert is a false alert. So it reminds me of a story where my friend Kuba, he was having an on-call, and at the same time, and he had a newborn baby back then. So at the same time during the night, his baby was crying and his phone was crying with PagerDuty alerts. So he wasn't sure what to look at first. But important thing is that you really put focus on it. So for us, definition of unactionable alerts is quite simple. It's an alert that was automatically resolved under 2 minutes, because this 2 minutes is such a time period that you can be sure that there was probably no human intervention involved in resolving that issue. So we started tracking that, and then we make sure that there are needed action points in the team's backlog, that they fine-tune the thresholds. And this is actually a chart from a previous company I worked for, where we were tracking number of people responding to incidents as over hours. And just by looking at that metric, just by making sure that we really act on it, it decreased pretty much 10 times. So, and that doesn't even show the number of disruptions during the day if you have unstable monitoring. So another thing that is quite important when you are thinking about setting up alerts is making sure that those alerts, they have enough information in them. So things like runbook instructions are included. Because, for example, at Zappo, we have now on-call set up, so we have 24/7 coverage, and there is one backend engineer and one SRE engineer. So you can imagine that person will never know the whole system, so it will never know all the domains. So if it comes, if an incident comes from a domain that person doesn't work day to day, it's really good to have some kind of instructions what to do first before trying to escalate. So one cool thing about PagerDuty that we use for that is that it has a feature called automation actions, where you can actually add possibility to run certain scripts even from your phone. So let's say, for example, that that service is legacy and sometimes it needs to be restarted. So you could just have that included in the alert and just press a button from your phone and restart that service. But it could be also a different script depending on your needs. So the next step then would be to actually create an automation for that, so that the incident is not even escalated. So you know that the system tries first to execute that script if there is an alert, and then only if it didn't work, escalates it to the human. So third level here, which I feel is really important, and this actually even more says even more so why I like DevOps culture among engineers, is domain metrics. So domain metrics, in my opinion, have two categories: business metrics and technical domain metrics. So there is a story I wanted to share with you, why I think this is so important. And when I was working in a company that was doing an application for sending money abroad, there was a possibility to pay with a card, and that money would then arrive to the recipient, usually in a different country. And one day on Friday afternoon, ironically, this integration stopped working, but there were no errors. So our vendor was still replying to us with 200, like everything was fine, but this didn't work. So the payments were not being processed. And we found out about that only from customer support, which told us that there are more and more complaints about that. And when we were doing a post-incident review on that problem, we saw that it was actually really important to think about domain metrics, because not having errors doesn't actually mean that everything is working fine. So in that case, we introduced a pair of payment created, payment completed, and we were tracking how much disparity is between the two, and then raising an alert. And then it helped us also a few times in the future. So like I said, but there are also technical domain metrics, and I would like to illustrate the difference between those two, and also difference between the golden signals on two existing services at Zappo. So if we look crypto in and out subdomain, if we take two services from that subdomain. When you think about the first level, so about setting up baseline monitoring, you don't really need to know what that service does on the domain level. So the technical nature is so which kind of technologies it uses. So in this case, Circle, it uses, it's a web service exposing an API, and it uses an RDS database. And then there is Crypto, which is an asynchronous processor listening to the queues that also uses RDS. So when you think about the first one, saturation, going from the end a bit here, those things will be the same usually for most of your services. So here you track CPU, memory, storage. Then when you go to errors, you can already see the differences. And by no means this is not an extensive list. Of course, those are just examples. But Circle would then like to track 500 errors, and then on the async processor, you would be more caring about errors when reading from the queue. So on the traffic, on the throughput, you track HTTP requests per second for the API service, and then on the Crypto service, you would track messages processed per second. And then latency, the similar thing, HTTP response time on the API service, and queue processing lag to know how many messages are in the queue and are being processed on the Crypto. So when you go to the next level, so when you start thinking about domain metrics, then you of course need to know what that service does. And this is where it's really good to have backend engineers involved into that, not only rely on operations team. So in our case, service Circle is responsible for integration with Circle, which maybe you know, it's responsible for USDC stablecoin. So it provides deposits and withdrawals for USDC. And then Crypto is an internal service that then aggregates data from different services of this kind. So it also then processes USDC, but USDT and Bitcoin and some other coins in the future. So when you think about technical domain metrics, you stop thinking about metrics on one service level. You think about the whole subdomain. And here, for example, one of such technical metrics is number of available deposit addresses, because we need to provide deposit addresses on demand, and because we want to have some kind of resilience, we maintain a pool of those addresses on our side, so in case third party goes down, we at least have some leading indicator if that pool is decreasing too fast. Other would be number of failover providers. So your business metrics might be still working fine, but if you see a failover every 5 minutes, it's probably something worth looking at. But those are still the things that would be more interesting to engineers, not so for non-technical stakeholders. So when you then go to the next level of business domain metrics, those should already be things that your PO should understand, maybe even your CEO, actually. And in this particular example, we track number of total deposits, number of total withdrawals, withdrawal failure rate, and much more. And this is an example of a dashboard that tracks those things. Here, this is still work in progress, so teams are still thinking which kind of additional domain metrics are worth tracking and which kind of alerts we should have there. I wanted to also show you another team's dashboard. This is actually about risk, so transaction monitoring. And here we track, for example, pairs of risk analysis started versus completed. Again, if that disparity becomes too big, we raise an alert. There are different counters, for example, number of pending analysis. And again, if that counter becomes too big, we also raise an alert. Interesting thing that you can see here, there are also technical metrics here, like errors 500s or SQS lag. But the difference here is that those are not per service anymore. This is aggregated data for that subdomain. So it's actually easier to navigate through that if you want to have a more high-level view. And then having that data should allow you to create high-level monitoring dashboards. And I remember when I joined Zappo, I was December 2021, and I had the pleasure to witness AWS outage. So some infrastructural pieces went down, and the services were written in a robust way. When the AWS pieces recovered, the systems went up. But the problem with that at time was that we really didn't have good idea what was working, what's not working. So Back then, we were in a different spot when it comes to observability. And what was needed was for the tech leads and their team to actually go into their services, check the logs, check the low-level metrics, and then start reporting upwards, okay, this is working, this is not working. So for us, for example, for me or for CTO, it's actually very important to have a place where we can go and see what's working, what's not. And you can actually then later even transform that into a status page for your customers, or at least give it to customer support so that they have better idea how to respond to requests. So for that, we used a tool, a feature actually from New Relic, but it doesn't matter how you implement it. The idea is that you just know that something like that is really nice to have and something to be thinking about. And here, workloads, we have different types of workloads that we track. This screen shows our teams. So we call our team SATs, so it stands for Stream-Aligned Teams. So if you have read Team Topology's book, you will know what it is about. But basically, those are self-sufficient teams that should be able to autonomously handle stream of work coming their way, usually somehow connected to subdomains as well. So we have 8 of them. The one in the middle, the gray one, doesn't exist anymore, but it's not yet cleared from New Relic. It has been split in 2. Customer acquisition and onboarding, and financial crime prevention, because they can now work more efficiently like that. So I was actually quite lucky when doing this screenshot, because I caught an error on the crypto team, and it was during the release of USDT withdrawals actually. That was also triggered an alert, and the team fixed it quite fast, but I was actually quite happy. I said I'm going to leave it for the presentation. Because when you click on that rectangle, then it shows you a more detailed view of the services that belong to that SAT, to that team. And then if you click on one of the red ones, you will see that the problem was with service Transa, which is our transaction ledger. And this is another view of kind of similar thing, but instead of teams, we divide it by bounded context, because we use domain-driven design at Zappos, so this is how we track. Not everything is still populating data, that's why some of them are still gray, so it's also a work in progress. But the red one is, again, transaction ledger, so if you would click on that one, it would show you also that Transa had a problem. And then the cherry on top for that, in my opinion, is automation of service level indicators. Like I mentioned in the beginning, if you cannot do that before, even if you have a tool that would do that for you, because the data would be simply unreliable. If you cannot trust your alerts yet, or if you don't have even enough data populated into your systems, then it would simply not something you can rely on. When you think about SLIs, in case you don't know what it is, those things should be considered together. SLA, SLO, and SLI. And SLA is a service level agreement that you do with your customers. With other words, it's a promise to your customers. And that promise usually has some kind of SLO inside, so some kind of objective that you want to meet. And that objective can be, for example, you want to have 99.95% uptime throughout the year. And then SLI is simply how well we did on that goal, on that objective. So the real numbers behind that performance. And just to sum it up, just to wrap it up, if you want to see if it's something you want to focus on, I really recommend you using data to evaluate that. If you don't have the data yet, you can start tracking this even manually. Start with customer support. See, you can even put it in a spreadsheet to begin with, and then think about automation. But once you decide, okay, reliability and observability is something worth working on here, then I really recommend checking out this prioritization and then seeing, okay, which levels maybe you should be focusing on a bit more. That then should allow you to create more and more automation, so that less and less human interventions are needed in certain areas, and also stabilizing the whole platform in general. But here you can think about, automatic failovers, automatic restarts if needed, or even if you don't want to rely on scaling through your cloud provider for some reason, you could also try to make that a bit more responsive. And then this is a continuous effort. So whenever you add new features, whenever you create new teams, you should still make sure that this simply becomes business as usual and that you kind of revisit those things whenever needed. And yeah, because it's about the journey, it's not about destination, so you will never fully arrive there, but it's just something to make sure it's incorporated in your day-to-day work. So yeah, if you have any questions, please enter them in Slido. I'll have a look. Let me. Where can I do it full screen? Yeah, cool. So just one question: where can you find presentation? It's a good. I can put it on LinkedIn. Simply make sure. But I think it will be also available on GeeCON, right? I'm pretty sure they will make the slides available. No other questions. Thank you. In that case.